we discuss about the neural networks theory concept. Now we need to apply these neural networks in our TensorFlow backend. So now to apply this neural network, we chosen TensorFlow as a backend and Keras, all those libraries we are planning to deal with this. So for this perspective, you should not always open the our Anaconda prompt in the normal method. We need to open our Anaconda in our TensorFlow environment. So let's we start to build our neural networks. This is our basic neural networks. So first we will discuss about the problem statement. So this is the bank data set. This is not a real data set but is a realistic. So now this data which is contains 10,000 customer details. So totally you are having a 10,000 rows. So now what the bank is actually asking us to do is, it's asking us to know about the churn rates of the customer. So what is this churn rates? This is nothing but the people leaving the company. So it's like something unusually the peoples are leaving the company like anything. So now we need to access and analyze this problem. Why the peoples are leaving this company? This is what our problem statement is. To understand what the problem is, we need to access and we need to address this problem. So someone hired you as a data scientist and they just giving this data set and they are asking you to insight this. And this data set is the part of France, Spain and Germany, and they have lots and lots of customers. What they did is they took. So if you the one, that means the person is no longer for the bank, is that person still for bank. Your goal is to create a demographic segmentation model to tell the bank which of their customer are the highest risk of leaving. So after you are just telling the highest risk of leaving, probably they may give some offer or something to make the customers to be with them. So this is our business problem. So this is how to import the Keras. So we are just importing the Keras first, and this is like you are just initialize the ANN and you are just going to build the neural network. So this all the steps, following steps we need to implement. So then you need to initialize the ANN. So to initialize, we are having the sequential. The sequential is an object of the class which is used to initiate our artificial network. So after this, we used to get this 11 variables. So y and x is an output and data expected, predicted, your y prediction, x text, x train, minimum, maximum, all those data. So you are just going to implement all this step. Randomly initialize the weights to small number closest to 0. Input the first observation of your data set in the input layer and forward propagation from left to right. And compare the predicted result to the actual result, measure the generated error. And then back propagation from right to left. So this all the steps we need to implement. So this is the second step. About the second step we already discussed in our theory part, and now here we need to choose. Here we just chosen the sigmoid function. So if the output is closer to 1, the electrical signal will pass, like our brain. If its output is closer to 0, the electrical impulse it won't pass. So based on this, the second step will work. So this is how our sigmoid function work. Here we are choosing the sigmoid function because it will give much better option to build the logic. So after this, our third step. So our third step is, what is your output is a binary or a continuous. So if it's binary, that's nothing but a 0 or 1 in a data type. We are choosing our rectifier activation function or a threshold activation function. Any one we are applying as in your third step. So this will give you the output value. So now we need to start to implement each and everything in our TensorFlow backend. So to install the TensorFlow, first we need to install pip install TensorFlow. So and then we need to install our Keras, and then we need to start with our basic pre-processing step and basic data reading steps. So now we are going to start with our basic pre-processing step first. So as like same, we are just going to import our NumPy in the name of MP. Then again what I am just going to do is I am going to import pandas in the name of pandas. So after this I am just going to import our matplotlib.py plot in the name of plt. So we just imported this 3 libraries. Okay. So now this is a spider where we are just planning to run. This is our output console. Here we will get the variable explorer. This is a file explorer in which path my file is open, which is used to get those things. And here we are going to create our project file. So let's we run this. Let's check if any error is there. There is no error here. Great. So let's we starts to get the data set. So as like we already told, this data set is nothing, not a real data set. This is a realistic data set. So I am just planning to create a variable name, and this variable name I am going to read underscore CSV. So make sure your CSV file is located in the same location of this file, else we need to give the complete path. And for me the file and CSV file are in same location, I guess. So CSV. So we just created this. So after I'll be just going to run. So great. So now I am not getting any errors, and here in a variable explorer, here we just chosen as a data set. So here also I am just getting as a data set. The next thing is, so now we just read the data set. So when here these are the variables which we are just getting. This is the variable name data set which we given here, and this is what is the type of data. So now when I am just clicking this data set, I can able to read my original data set here. So as like we already told, this is contains around 10,000 datas. And here we have a columns name like a row number, customer ID, surname, credit score, and then geography, gender, age, tenure, balance, number of products they are having with, either they are having a credit card or not, is an active member or not, estimated salary for them, and exited. So either they exit or not. So now when it comes to 0, they are already exited. So the peoples who are in 1, they may exit or they may not exit. So now we need to predict the things. So this is actually our data set which we read from our local drive. So now we need to start to build our x and y. So x equal data set, that's nothing but our variable name dot index locate, which is nothing but we are going to select this all the rows 3 to 13 column I am planning to take. So why I am choosing 3 to 13? So here first one is row number, anyhow we don't need this. Then customer ID also we don't need this. So and surname, here index, row number, customer ID. So from here I am just planning to choose till 13, and 13 is your exited. So when we are applying a slicing in Python, the slicing concept is always n minus 1. So 13 minus 1 is your 12. So the next thing is we will get from 3 to 12 the data set. So now we just created our x value. So the next thing is we need to build our y value here. So I am just going to build the y value. So all the rows 13th column. So now here we just created everything, but we need to give values as well. Then those values will be got from this column. So we just save. Let's we run this. Yeah, here we are not getting any error, and we got x data set y, and when we are just having our x data set, will be getting our data set, and when we are having clicking the x, you are getting object array currently not supported. So now this data type in a data set, it's actually in a data frame, but when you are just choosing this x, it's actually in the object, and when we are having in y, it's actually in integer. So all these are integers, so probably there is we are getting this thing, but when you are choosing x, it's in object, it's maybe in the array format. So this format, it's not supported to open in Spider. So anyhow, we just splitted our x and y, and our y is an integer, so easily we read this. Okay. So now the reading step is done here. We need to start with encoding the categorical data. So that is what our next step is. So here, to encoding the categorical data, we need to start with our scientific Kitlan pre-processing step. So I am just giving pre-processing. I am just going to import label encoder and one hot encoder. I am just giving a label encoder and I am just giving one hot encoder. So what is this label encoder and one hot encoder, which is used to convert the different objects into numbers, and one hot encoder where it's already like in integer 1010. Now we will get 0 as one column and 1 as another column. So if the value is 0, here we'll get 1, and for 1 we get 0. So let's we start to build this. So I am going to create one variable name called label encoder x underscore 1. So for our better view, I am just giving like this equal. What we are just going to do here is I am just initiating my label encoder here. Great. After this, what I am just going to do is I am going to get only the first column. So here we already chosen 3 to 13. So only the first column, all the rows from first column, I am just applying this label encoder underscore x underscore 1. I am just going to apply my fit transform. So fit underscore transform. So here again this we are going to save, and this transform we will be applying and changing to our first column. Great. Now what I am just going to do is, so we just created this and we just apply the fit transform, everything is done. Okay, here we are getting some yellow line because of warning. Here label encoder, we just missed the R. Okay, now it's not there, so it's working fine. And here we gave a small x, but here we gave a caps x. That's the reason here you are getting still warning. So now everything is works fine. So here and here, that's all fine. Great. For our better performance and understand, let's we make everything in a caps. So nothing but for my better understanding, I just given. So label encoder x underscore 1 dot fit transform. Okay, here everything is fine. Okay, let's see if we are getting any error. So now again I am just creating a one more label encoder underscore x underscore 2. So now again here I am going to initiate my label encoder value. So now what I am just going to do is, this I am again going to apply for my second column. So again label encoder underscore x underscore 2 dot fit underscore transform, where we are going to apply this in our x all the rows second column. This is what we are just going to do here. Great. We just chosen this label encoder for first row and first column. So now I want to apply this categorical feature. So for that perspective, what I am just going to do is, okay, first I will run this and will check is there any error, is anything coming here. So it's still running, so we need to wait. Probably if we are getting, okay, label encoder is not defined, so we are just getting our yeah, so that's the error here. This is a spelling mistake. Yeah, so now there is no warning at all. So let's we run our thing. Okay, then again one more attribute error. Okay, I guess everything is fixed down. Yeah, great. Now we don't have any error, all the errors are fixed. So now our thing got run. Okay, so now we'll now open our X. Still your object is not converted. So now I am planning to convert my X into my one hot encoder. So to convert to my one hot encoder, I am just going to create one variable called one hot encoder, and then what I am just going to give is one hot encoder. This is a case sensitive, so I just give everything small for my variable name, and what I just give is categorical future. So like how many categorical future, like I want to make those. This is another positional argument which we can able to pass here. So now I pass this positional argument here. So now I am going to apply this one hot encoder in my X. So I am just applying one hot encoder. So in one hot encoder, what we are just doing here is one hot encoder dot fit transform. So here we are just getting the suggestion. So fit transform of our X. This is the argument which I am planning to pass, and this is our caps X. Always we need to be make sure about our case sensitive to array. So if I am not converting to array, then here we can't able to get the result. It's not in array, that's the reason we are not able to view here. So now I am just running this. Okay, here we are getting a deprecation warning. So deprecation warning is not the big deal. So this categorical feature keyword is deprecated in version 0.20 and will be removed in 0.22. You can use column transformer instead. So this categorical feature, it's already deprecated in 0.20 version, and now in 0.22 version it will completely removed. So instead of categorical feature, we need to use this column transformer. So I just copy this, and instead of this categorical feature, I just give column transformer. So we run this. Okay, column transformer is executing keyword argument. It's not allowed here. Okay, probably we need to do some research for this column transformer. So right now we'll go ahead with our old argument itself. So maybe in future we will apply this deprecation stuff. Okay, so now we just apply our one hot encoder and a label encoder. So when I am going to open this X, wow, this all the things which is converted to your one hot encoder. So where one hot encoder, it's actually you converted for the first column, so you'll be just getting all those things. So after this one hot encoder, you will be just getting everything to be converted. Yeah, here we just converted and saved in X data type. So that's the reason we just created a one more X. So but I don't want that X. So I am just planning to give the caps X here. So my one hot encoder will again save in my caps X. Okay, so probably it got run. We open a X. Great. So now we are having all the data which is converted to our categorical data. So now again I am just going to do one more step for my future thing. Just applying from 1 to all the columns. I am just applying this. Okay, now we just encoded our categorical data here. So after this, what we need to do? We need to split our training and testing data set. So our next step is here, training and testing data set splitter we need to do. So these steps we already discussed. So I am just going to give from skitlan dot model underscore selection. So we from this we are just going to import our train underscore test underscore and split. So after this x underscore train comma x underscore text comma y underscore train comma y underscore test. This all the 4 arguments we are going to create as a variable name. So train underscore test underscore split, we are going to apply it for x comma y comma test size. So this is your test size. So you can able to give anything. So here I am just planning to give 0.2, that's nothing but our 20%. So we just give our test size as a 20%, then we need to give one more mandatory stuff, that is nothing but our random state 0. So this random state we can give any numbers. Okay, so we just apply our training and testing split here. Now we need to standardize our thing. So for this standardized purpose, so we are planning to apply our future scaling. So now for this future scaling, what we are just going to import, that's nothing but from sklan dot preprocessing, I am just going to import standard scalar. So now variable name standard scalar. Yeah, we just created this. Okay, there is a spelling mistake. We need to give standard scalar. Okay, so we just initiate the standard scalar method. Now we need to make this with our training and testing. So our variable name x underscore train equal, I am just going to apply this fit transform here for x underscore train, and the same thing we are just going to apply for our test. So sc dot fit underscore transform x underscore test. So great, we almost apply all the pre-processing step which is mandatory to get into our deep learning. So to check either there is any error or there, I will be just running. We are getting only deprecated warning. Great. Here now we are getting the variable of y train, y text, y data set, x train, x text, x. So x our x data set and data set is our actual data set, and x text, here we can able to view what are the text data set which is considered from by our machine, and x train we can able to view what is the training data set that is viewed here, and y train and the data of our y test, everything is be here. So the first step we imported the libraries, the second step we read the data set, then we applied label encoder and one hot encoder, then we applied our training and testing data set. Now we applied our future scalar. So great. Now this is the way. Now we need to start to implement our package, our Keras package, and we need to run this in your TensorFlow backend. So this is the bank data problem which we are going to deal with this now. Now the first thing in our neural network building is we need to make importing our Keras library. So we already built some machine learning model. So for that, first we used to do with all our pre-processing step, everything we used to perform that. So that pre-processing step only now we did. So after this pre-processing step, we need to import this library and we need to make sure about everything is working fine. Okay, so now this all the three frameworks, so this is the library, and inside this library we are just going to import these three packages in our spider. So this is your part 1. Whatever we did, it's a pre-processing step, it's our part 1. Now we are just going to start with our part 2, that's nothing but ANN building. So now the first step is you need to import the library. So I am just import my Keras, and from Keras model, from Keras models, I am going to import my sequential. Okay. So this sequential which is used to initiate the model. So this is the library which mainly used to initiate the model. So the next step what we are just going to deal with, from Keras, I am just going to import the layers. I am going to import, what I am going to import, that is nothing but the dense which is used to build the neural networks. So we'll be just going to run this. We already run the previous part, so let's run the new imported stuff. So using TensorFlow backend. So these libraries, everything which we will be dealing with our TensorFlow backend only. So now we imported this thing. So now, as like our slide, we need to initiate our ANN stuff. So here we imported this library. So the second step, we need to initiate this thing. So how to initiate? This is our variable name, classifier, and sequential. The sequential is an object of the class which is used to initiate our ANN library. So here we already imported the sequential. So it's a caps S. So from Keras model you imported the sequential. So now we are going to initiate these things. So for this initiate, I am going to perform classifier equal sequential, open bracket, close bracket, it's done. So now we just imported our we just initiate our ANN. Okay, it's done. So our next step is we need to start to add the input layers. So here this all the 11 variables which we already done. So we are just going to start to apply each and every step here. So as like this is our theory concept, now we need to start to add our input layer and our first hidden layer. So our input layer to add, we need to use this thing, classifier dot add. So what is here classifier? The sequential initiate stuff and add. Now I am going to add the input layer. So dense, which is used to build the neural network. So I just give the dense. So how many units you want to build with this? So that's we are just giving. So kernel initializer, this is nothing but the distribution we need to give. This is nothing but our distribution. So uniform distribution based. So the activation, that's nothing but the rectifier. So the input dim, that's nothing but how many input node you are choosing. Here we are choosing total 11 input node. So here you are choosing this activation step is a sigmoid, but here I am just choosing, like this is for the theory concept to understand the things we just discuss about all these things. So then this threshold function or the rectifier activation function, the sigmoid or rectifier the same. So now I just choose an activation as a rectifier, that's this RELU, that is nothing but your rectifier function. So this is the script where we need to add with our input layer. So Here this is our actual input layer. So units, that's nothing but number of nodes will having an input layer, and this is nothing, you are having how many independent variable in your matrix. So input layer plus output layer divided by 2. So how many input layer we are having? 11 input layer plus 1 output layer divided by 2. Yeah, so how it's we are choosing? So we are just having the 11 input layer. When you are just choosing X train, so totally you will be having a 11 input layer. So that's what we builded in our X also. So in this X, it's actually total 11, but we already converted into our label encoder, all those things. So 0 to 10, total our 11 input layer. And then how many output layers? Only one. They are going to stay with us or not. So only one output layer. So that's what here we are mentioning. So input layer is 11 plus only one output layer divided by 2. This is what our unit is. So now our unit is 12 divided by 2. So your unit output is 6. So kernel initializer uniform. So what kind of distribution method you are planning to apply? You can choose Poisson distribution, binomial distribution, everything. Here we are just going to apply our uniform distribution. So this input dim, our input layer, we will have total 11 input nodes. Then the third step is for our propagation. So this we are mainly choosing for our propagation technology. So from left to right, the neurons are activated by the activation function. In this such a way, the value of the higher activation function of the neuron will make the more impact. So the neuron is going to have in network. That means the more it will pass on the signal from the nodes on the left to the right. So the speaking of activation function, which will have to do this, the define first hidden layer in the chosen activation function. So we are chosen activation function as a rectifier, and this is for our hidden layer and input layer. Then you are having a sigmoid, so sigmoid as our output layer. So this is the first step to add our input layer. So let's we start to add our first input layer in our script. So classifier we already imported, so I am just giving input layer. So now we are just going to add our input layer, classifier dot add, because I am going to add it. So what I am just going to add is I am just going to initiate the dens and the units. So this units, that's nothing but what we want to make, 6, and then kernel underscore initializer. So this is used to give your what kind of distribution you want to implement. I want to implement the uniform distribution. Then activation. So what is our activation function? Here you are planning to use, that's nothing but rectifier. So after this we need to apply the input dim. So how many input node will be having? 11. So we just built the first input layer. So this input layer, let's we run in our spider. So it starts to run kernel initializer. This keyword argument, it's not understood by our backend. So keyword argument not understood. So we are having around dense unit 6 kernel. Yes, now it will be fine. So let's we run this now. So probably we are not getting any error, we are just getting only the deprecation warning. So we don't need to worry about the deprecation warning right now. Okay, so now we just created the first input layer as like our theory concept. So the next thing is we need to add the second hidden layer, and this is the script for second hidden layer. So let's we discuss about how this hidden layer is working. So classifier dot add dense, we know this is for to create the neural network, units 1. Now we are just taking the units 1. This is for our output layer. So this input layer is 6, like the same like our input layer, like these 6. And here there is kernel initializer, that's nothing but a uniform, and activation is relu. Here we are not using this input dim. The reason is this is the hidden layer. So to add the second hidden layer, there is no need of much. We need to use the same thing. So let's we create one command, hidden layer. So here we are just going to handle a very small task. So only one hidden layer is more than enough. So depends on our class and everything, we need to choose our hidden layers. So I am just using a dense. So inside the dense, now we are just going to give a multiple arguments. One is units and another one is kernel underscore initializer. Yeah, so we are just making the kernel initializer, and here also you are just going to apply your uniform distribution only. So nothing else, we are simply going to apply our uniform distribution. So after this activation function, here we need to give. So activation also we are just going to handle with our rectifier. So now we added the hidden layer. So this is the hidden layer, so no need of input dim. So this is how we are just going to categorize our hidden layer from our input layer. So we just make this done. So our next thing is we need to get our output layer. So positional argument follows. Okay. So now we may run, we will be getting the output. Okay, great. Now there is no error. So we just apply the pre-processing step. We just initiate the neural networks. Now we just did your input layer and we did our output layer as well. So now we need to make sure about compilation. So compilation, that's nothing but we need to make our output layer. That's what our compilation is. So now what we are here going to do is we need to discuss about how the output layer will work. So classifier dot add, this is nothing but we are just going to add the dense units equal to 1. Why here units is equal to 1? Because only one output layer. So if you are having a 2 output layer, so your output is a continuous variable and it maybe contains 2 or 3 output layer, then we need to go ahead with the 2. So kernel initializer, so now we are handling with the uniform, and then activation function, that's nothing but your sigmoid. So this is your hidden layer, so no need of input. Okay, now this is our another hidden layer, so no need of input. Okay, so now we are just going to, this is actually our output layer, so no need of giving an input. This activation, everything is our sigmoid. So now the expected output is 0 and 1. 0 means if customer leaves, 1 means if customer say. So output 1 because it is a categorical data. So classifier dot compile, optimizer, loss, matrix, this all the things we need to make in your compile. So the compiling the neural networks. So what is this optimizer? Simply the algorithm we want to use to find the optimal set of weights. You know, we define our neural networks, it's built with the different layers, but the weights are still only initialized. To apply some sort of algorithm, we need to find the best weights that will make our neural network the most powerful. So this Adam, it's nothing but a gradient algorithm and it's a very efficient one. And here in this optimizer, we are just applying our descent algorithm, the gradient descent. And then here this is our simple linear regression. The sum of y minus the actual input minus the predicted output. So we are just going to calculate the ordinary least square value. So this ordinary least square value is based on this thing. So now what we are just going to do, so your salary is always based on your experience. If your experience is high, you will get the more salary. So this is the simple linear regression task. So in your output layer, we are going to get this logarithmic class. So when you are just having this loss binary cross entropy, so how to choose this? So if the output layer is a logarithmic loss, so simply if your dependent variable has a binary output, then the function called binary cross entropy. If your dependent variable has a continuous outcome, that's nothing but more than 2 outcomes, then it is known as a categorical entropy. So now here we are having a binary outcome, so we need to choose this as a binary entropy. So this is actual output and this is your predicted output. So logarithmic loss is worked based on this formula. So summation of all those things, log of our sigmoid plus 1 minus 1 again the log of our sigmoid. So this is your index of future and this is our sigmoid function and this is our index of observation. So the actual for 0 and the actual for y. So if we are getting some values which is less than 0.5, so 0.5 or less than 0.5, we will be considering that as a 0. So 0.5 more than 0.5, we will be considering that as a 1. Because when we are just applying, our output will come as like our 0.7, 0.2, 0.3 like this only. So based on this output, anyhow we are not applying the continuous things. So it's only binary outcome, so we'll be just getting like this. So adding the output layer, we need to add one more argument, that's nothing but a matrix. It is used to evaluate our model. So in our previous linear regression, all those things, we used to choose this matrix as a accuracy score and then RMSE, those kind of criteria. And here we are choosing this matrix to evaluate your model. It have only one, it's nothing but your accuracy. So the matrix which is nothing but your accuracy. So great, this is your output layer. So where you are having a neural network which looks like this. So input layer we built it and hidden layer also we built it. The sigmoid function we just applied and this is the third step. Now we are just applying our third step, that's nothing but our output layer. So let's we apply our third step here. So in our third step, what we are just going to do is classifier dot add. What we need to do here is we need to give our dense. So this is our output layer. After giving the dense, we need to define about the units. So this is our output layer. So I am just giving only 1 unit and the kernel initializer. The kernel initializer which is used to make our which kind of distribution we need to add. So that's the thing which we want to make. So this kernel underscore initializer which is used to get the uniform distribution. So after this we need to give our activation function as well. So I am just giving activation equal. So what is our activation function? That's nothing but our sigmoid. So that's we just give here. So this is what the sigmoid which we will be giving. Okay. So now this all the things we need to give. Classifier dot add where this is the output layer. So I just give units equal to 1 and the kernel initializer, it's nothing but the uniform distribution and your activation function, that is nothing but your sigmoid. So let's we run this model. If there is any error, we'll get great. We are not having any error here. Great. So now what we need to do is we need to compile your artificial neural network. So here you add the output layer, it's not more than enough, we need to compile it. So compilation is actually here, we need to choose classifier dot compile. What we are going to compile here, that is nothing but optimizer equal Adam. So after this we need to tell about what. So here you are going ahead with binary output. So binary underscore cross entropy, and then what we are just going to do is matrix equal, what we are just giving, accuracy. Okay, great. So now we just did our classifier dot compiler, optimizer, Adam, loss, binary cross, entropy, all those things is done. So now we just compile it. So let's we run our compilation here. Still running this, only one line is enough, but for my satisfaction I am just selecting everything and I am just running it. Okay, so now we compile our neural network. So we will be going ahead with the next thing, that's nothing but a fit transform. So we need to fit our neural network to the training set. So this is the script line, fit x train, y train, batch size 10, epochs 100. So the batch size, it may be, we need to give only integer, nothing else, we need to give only integer. So number of samples per gradient update we need to give, and specifically the batch size will be default to 32. So batch size is used for number of observations. So now we need to get number of epochs, that means nothing but how many times you want to go through the training set again and again. So epochs, it always comes as an integer. So number of epochs to your train the model, the epochs is an iteration over the entire x and y data which we provided. So now we need to apply these things. So this is the final step in your neural network. So that is nothing but fitting your ANN. So fit ANN step. So now what we are just going to having here is classifier, that's nothing but the output. Now what I am just going to do is fit. So here what we need to fit here, we discussed x train and our y train. This is the thing which we need to fix, and the batch size. So batch size is always our none value, else our integer value. So I just give batch size equal to 100 and then epochs. So this is nothing but how many times we want to run this to. So total 100 times. So great. We just run this. So let's we run this. Okay, let's we run this. I'm just running this. Okay, great. We will be just getting total 8000 times. It's just getting run. So total we gave batch size 10 and epochs 100. So this will go and run this training data set again and again and again. So this is how our training data set will run. So every time if you see, we will be getting the accuracy score 0.83. Now here we get again 0.83. So here now we got again 0.83. So here when this batch size is running, we will be getting the accuracy. So 0.82, 83, 82, 83. So obviously we will be getting this accuracy for 0.83 only. So let's we run this. Parallelly, we will write the another thing, part 3, which is nothing but evaluating the model. So here what I am just going to given is a y prediction. So what I am just going to make is a classifier underscore predict. I am just going to make this text, and then what I am just going to given is a y prediction equal y underscore prediction, which is greater than 0.5, So let's we make our confusion matrix. So what is our confusion matrix here? So which is used to understand what will happen, like how much accuracy our thing is. So that we need to import from our scientific kitlan matrix. So I am just import confusion underscore matrix. So the variable name confusion underscore matrix. Now y underscore test comma y underscore prediction. This is what we are just going to apply. So let's our epoch we gave total 100, batch size 10. So for 10 batches 100 epochs it's run. So it's run only for 59. So for this much level our neural network will go and run again every time. So to get the more accuracy score we will be just applying all those things. So we need to wait till our 100 should be run. So to run this neural network in our deep learning, so we need to get a very good configuration system, because we are running this around for 8000 times. So this 8000 times we need to run within 2 minutes or 3 minutes. If your system is not having a very good configuration, it will take too much of time. So this in our office we used to run all those things in a cloud. So for that we having some virtual environment setup and the virtual machine setup, everything. So this 100 epochs which is used to run within 2 to 3 minutes. So the more speed our system configuration, it should be good. So now it's already reached 88, now 89. Your accuracy score still we are having 83. So now we are in our 90, 92, great. It's now going little speed. Okay. Still we need to go ahead with 6 epochs. Okay, so the total accuracy that we will be getting average 83% each and every epoch. So when you are just checking everywhere, it's almost coming 83, 83, 83, 83. But when we are running it in, we used to get 70, 80, sometimes 90. See here in the first epoch, I guess this is a first epoch. We get a 79, so then 79, then 79, then 79, slowly we got 81, 82, then again 82, 83, 83, slowly it starts to increase 83. So we are just getting the accuracy score of 83, but started from 79. So this is how our thing is work. So the thing is like how you are just going to apply your neural networks. So when you are just applying these neural networks, so it first starts to read all your files, so which is giving like 79%. It's again going to the training data set and again it's reading. So we got 80. So then we got 81. Then we got 82 and then it's increased to 83. So slowly the accuracy score is increased. So how it's actually when we are just applying with the basic linear model, maybe for this problem we get 79% accuracy only. The reason is it just to go only one time with the training data set and read the training data set, and it is giving you the 79% accuracy. But when we are applying in the artificial neural network, in our neural network, actually it's again and again and again it's running to our data set. So that's the reason we will be slowly, our accuracy score is improved from 79 to 83. The reason is our training data set, it's readable again and again. So multiple times it was read by our machine learning. So that's the reason we will be just going ahead. So again I just run, so it started to run these things. So this is how your neural network works. So to start with your neural network, first we need to do all our basic building functions, like we need to import our numpy, pandas, all those things, and we need to read the data set and the pre-processing steps which is common for all those things. Then we will be just importing the module, and this is nothing but our input layer, which in our PPT where we will be having this input layer like this. Yeah, this is your input layer. So this input layer, that's nothing but this one. Then we was having a hidden layer, that hidden layer we just added here. So again this compilation that's nothing but our output value. So which function base you want to get the compilation? So after our output layer is added, we want to get the compilation output. So here we will be just applying what is your output. Now here we are expecting in a binary, so we just give a binary entropy. So fitting with the transform, so this TensorFlow, it's running for batch size 10 and epochs 100. So first time we was get 79% accuracy. It's first time readed by the training data set. Again we are getting 89, again we get 81, 82, 83. So the finally from 79 to 83, that totally we almost reached 4 to 5 accuracy percentage. So to get more accuracy percentage, our neural network is reading the training data set again and again. The more it read, the more it understand. So but the performance is little slow. So for that perspective we need to give the high end configuration 16. So this is what we need to consider in our basic neural networks. So our next thing is we need to create our RNN and CNN.